Hi dear students, to my channel Mathematics Made Easy. This is Miss Ritika welcoming all my grade 9 elite math students to today's video. This video is part 3 of the end of term exam coverage for math, and in today's video we are going to be working on trigonometry. So our learning objective would be to solve the end of term exam coverage questions related to trigonometry module 13. So we'll be solving, as you see on the screen, from page 783 to 814 these questions which are mentioned. So very important video. You must watch this video till the end of the video. It's going to be a long video because we are going to try and complete many questions of trigonometry. So make sure you stay glued, stay subscribed to the channel and don't miss any notifications. So do press the bell icon and like the video if you find it useful. Share it with your friends who are going to give their exams very shortly on 13th of June so that it helps them also. So let's solve the first question. Now for these questions, we'll be using the formula sheet of the 5 important identities. So we are going to use quotient identity, we are going to use reciprocal identity, Pythagorean identity, co-function identities, and also the even and odd identities. So make sure you learn them so that you are not confused, and while we are solving questions, you are able to use them for the same. So here sine value is given to you. You need to find the cos value. Also you are given theta lies in 0 to 90. So this is first quadrant. And in the first quadrant, when your sine is this value, you need to find the cos value. So that means you are going to use Pythagorean identity since sine is given, but you need cos. Let's put the value. Simplify. So this is 1 minus 9 over 25, which is 16 over 25. This is the value of cos square. We need for cos, so we'll take the square root. Now square root will give you positive and negative both. But since it is first quadrant, cos will be positive. So the final answer would be the positive value only. So cos theta is 4 over 5. Answer for first part. Now let's move to second part. In second part, sine is given and you need to find tan. Now let's come to quotient identity. Tan is sine divided by cos. So can you find cos similarly using Pythagorean just like you did in part A? Yes, you may. So cos square theta is 1 minus 1 by 2 square, which is 1 minus 1 by 4 or 3 by 4. So again, cos theta would be square root of 3 by 4. So this is square root 3 over 2. I'm taking only positive value because I know it is in first quadrant. Now you have sine, you have cos. Can we find tan by using division? Yes, we can. So this is going to be tan theta is 1 over 2 divided by square root over 2. So tan theta comes out to be 1 over of 3. Now again it is positive because it is in first quadrant. Let's do question 3 on the next slide. Okay, so here cos value is given to you and you need to find cosecant value. Now cos and cosecant are not related directly, so we are going to do this question by an indirect method. Cosecant I know is related to cot. How can I write it? 1 plus cot square theta is equal to cosecant square theta. So in order to find cosecant, we need the value of cot. And in order to get cot, we need the value of tan. We can say that. So if cos is given to you, that means we can find secant. So secant, its reciprocal would be 5 over 3. Now 1 plus tan square, again I'm going to use Pythagorean, is secant square, which is 5 over 3 square. So from here you can get your tan square theta as 25 over 9 minus 1, which is 16 over 9. So now tan theta is going to be square root of 16 over 9. So we'll take the positive value 4 by 3. Now you got your tan, and because you got your tan, you can get your cot also. So cot is reciprocal of tan, 1 over tan theta, so it will be 3 by 4. Now let's go back to this identity. We needed cosecant in the question. So to get cosecant, we need cot, which we have got now. Cot is 3 over 4. So 1 plus 3 over 4 whole square. Simplify, solve the value, and this comes out to be 25 over 16. So that is the value of cosecant square. We need the square root, so cosecant theta is going to be square root of 25 by 16. Again, it is going to be just the positive value, so your final answer is cosecant theta is 5 divided by 4. Next, we move to the lesson of verifying trigonometric identities. So remember, there is a left-hand side, there is a right-hand side. Whichever is the most difficult, we start from that, and eventually we show that both are equal if the verification is true. So let's start with the first question here. If you look at carefully, cos square and cos square is common. So we can take it out, and inside you are left with 1 plus tan square theta. So which side we started with? We started with the left side because it is more difficult. Right hand side is only 1. So this is cos square theta. Let's use Pythagorean. Pythagorean identity says 1 plus tan square is secant square theta. Now what is the relation between cos and secant? They both are reciprocal. So this can be written as 1 over cos square. Now cancel the term. So because they are reciprocal, they are going to give you 1, which is the right side. So because both sides have come out to be equal, hence verified. So this equation is an identity, and we transformed one side, which was left side. Now let's do this one again. We will use left side because it is more difficult, and we will use the concept of reciprocal identity. So reciprocal identity says that we convert everything into sine and cos. So questioned identity gives you cot theta as cos over sine. Inside also we can take 1 over tan because it is reciprocal of tan is cot. So you may take this as cos theta over sine theta. Just simplify, take LCM. So this is 1 plus tan square theta over tan theta. Now use Pythagorean here in the numerator. So 1 plus tan square is secant square. So this reduces to cos theta over sine theta multiplied with secant square theta over tan square theta. Now convert everything into sine and cos so that we can cancel the common factors. So in the denominator we have to correct this. It is only tan theta, not tan square. So 1 over tan theta is same as 1 over 1 over tan theta is same as cot theta. So we can write cos theta over sine theta multiplied with cos theta over sine theta, and secant square is reciprocal of cos, so 1 over cos square. Now let's cancel the common factor. Cos and cos square cancel, so you are left with 1 over sine square theta, which is nothing but the reciprocal of cosecant square theta. Is it the right side? Yes. So left hand side and right hand side are equal, hence verified. So this equation number 2 is also an identity. Let's solve some more problems. We are now going to solve question 3 first, followed by question 4. So here I am solving answer 3. Let me divide here the space for all questions. Okay, so 1 plus secant square times sine square. This is the left side. We are going to begin with that, and we have to show that this thing is equal to the right side. So on the left, if I want to convert everything into sine and cos, then I can write secant as reciprocal of cos. So this will become sine square theta over cos square theta. Now sine over cos is tan. So I can write this as sine over cos whole square, which is nothing but 1 plus tan square theta. And now we will use Pythagorean. 1 plus tan square theta is secant square theta, which is the right side. So again, for this question, the identity is verified. So this equation is also an identity. Let's look at question 4 now. Again, in question 4, we will convert everything into sine and cos. This is already sine. Let's convert these two to sine and cos. So in the left hand side, you have sine theta multiplied by 1 plus cos theta, because this is reciprocal, multiplied with cos theta over sine theta. Let's cancel the common factors. Sine goes with sine, cos goes with cos. So you are just left with 1, which is your right hand side. Okay, we have some more space left. So let's do another question. So the next question we are going to be doing is number 5. Okay, it's a little long. Let's see if we can accommodate it here. So for this question, we are going to begin with the right side and then we'll come to the left side. Okay, so let's start with the right hand side. Right hand side, we are going to convert in sine and cos. So cosecant is the reciprocal of sine. So I can write 1 over sine theta minus cot is written as cos over sine in this way. And then there's a whole square. Now I can take LCM, which is sine theta. So this is 1 minus cos theta square. So let's open the numerator and the denominator. So denominator is simple. We can reduce to square. Numerator will be 1 plus cos square theta minus 2 cos theta. So I've used the algebra identity. Now in numerator, we can just simplify it a little bit more. So we can write it as, or I think it would be a better idea if instead of opening it up, we just write 1 minus cos theta as the two factors. So one is 1 minus cos theta, second is this, and denominator now we can replace by Pythagorean. So I'll be able to write this question as 1 minus cos square theta. So we will now use a difference of square identity in the denominator. So this becomes 1 minus cos theta times 1 minus cos theta over 1 minus cos theta times 1 plus cos theta. So we cancel the common part and we are only left with the left hand side, which is this. So we have verified left and right, both sides are equal. So the algebraic identity, I'm just going to write here that I have used in the denominator is a plus b times a minus b. This identity is called as difference of squares. Okay, let's do some more questions. Question 7 and question 8. I'm dividing the screen so that we can write them both here. Okay, so here the more difficult side is the left hand side. So we start from left hand side. And now we convert everything into sine and cos. So left side is, this term is already in sine. Now we'll convert this. So this is sine theta over cos theta, quotient identity plus reciprocal identity. Let's take the LCM. So LCM of this is cos theta. So you can combine your numerator sine theta plus 1. Now one is sine theta plus 1, one is sine theta minus 1. So this will be sine square theta minus 1. So again we are using the same identity, difference of square, which I wrote for you in the last slide. So this can be written as minus of 1 minus sine square theta over cos theta. And now we'll use the Pythagorean identity, minus of cos square theta over cos theta. Now cancel 1 cos theta, so you are left with only 1 cos theta, which is your right hand side. So left hand side is equal to right hand side, hence verified that it is an identity. Okay, let's do the next one. Now we are going to solve answer 8. Out of this, we again select the left hand side. This is a pretty easy question. We are using odd and even identity. So cos is an even function, sine is an odd function. Means Cos of negative angle minus of theta will also give you positive, whereas sine of a negative angle would give you negative value. So you can write this as cos theta times cos theta being positive, and sine will be negative, so plus of sine square theta. So this is cos square theta plus sine square theta, Pythagorean identity 1, which is the right side. So here also, hence verified that this is an identity since both sides are equal. Let's do the last two problems of verifying trigonometric identities. So here we are going to start with the left hand side. Secant theta minus tan theta. Let's convert to sine and cos. So this will be 1 over cos theta minus sine theta over cos theta. Just take the LCM. So what you get is your right hand side. Very easy question. Both sides are equal, so it is verified that it is an identity. So we have verified. Next one, left hand side, 1 plus tan theta over sine theta plus cos theta. We are going to convert everything into sine and cos. See, if you see carefully, this part is already in sine and cos. So just you need to plug in for tan. So what is the questioned identity of tan? Tan is sine over cos. So that's what you put in. In place of tan, you put sine theta divided by cos theta and then solve your question. Take LCM, 1 plus sine theta over cos theta. So if you take LCM, this comes as cos theta over sine theta plus cos theta. Now the common term will get cancelled and you are left with 1 over cos theta, which is secant theta equal to right hand side. So again, left hand side equal to right hand side. So it is verified that it's also an identity. So we have completed all 10 questions on verifying trigonometric identities from page number 789. Let's solve the last question for today, which is question 1. I will do this for you and you will try this one yourself. So let's do it. So here we have to find 4 things. So it's a pretty long question. And as you can see, it is on double angle and half angle identities. So we are going to use the following identities. I'm just going to write them for you so that you have a clear idea. The first identity we will use is for sine 2 theta because that's the first thing you need to find. So 2 sine theta cos theta, that's the first part of the question. Second part is cos 2 theta. So there are 3 identities for this. The identity we will use, which is easy for calculation, is this one out of those 3. Then the next one is sine theta by 2, half angle identity, which is square root of 1 minus cos theta by 2. And the last one is cos theta by 2, which is the half angle identity, 1 plus cos theta divided by 2. So let's solve them one by one. So here we need to sine theta cos theta. Sine theta is already given to you. So we need cos theta, and also you are given that these things lie in the second quadrant. So that will help us to decide the sign. So cos square theta is equal to 1 minus sine square theta. That's the Pythagorean identity we will be using. Put the value of sine. It is 2 by 3 whole square. Simplify 1 minus 4 by 9. So this is going to be 5 over 9. This is the value of cos square. Now we need cos theta, so it will be minus negative because second quadrant, square root of 5 over 3. So we have cos theta, we have sine theta. Let's put it in the formula. So your sine 2 theta will be 2 sine theta and negative value for cos theta. Simplify, multiply everything, and the answer will come out to be negative 4 over 9 square root of 5. Okay, so this is how you get your value of sine 2 theta. Now we need cos 2 theta. For this we need cos square, which is 5 over 9, already calculated, sine square, which is 2 by 3 whole square. So simplify 5 by 9 minus 4 by 9, which is 1 by 9. So that's your answer. So cos 2 theta is 1 by 9. Final answer for this step. This is the final answer for first step. Now let's come to this one. 1 minus cos theta by 2. Now cos theta already I have found. Cos theta is negative. So let's substitute 1 minus of minus 5 by 3 divided by 2. So this is square root 1 plus square root 5 by 3 over 2. Simplify, take LCM. So this comes out to be 3 plus square root 5 over 6 whole square root. And the next one, only if you see there is change of sign, so this will come out to be 1 minus square root 5 by 3 over 2. Again take LCM, so this is 3 minus square root of 5. So these are going to be the answer for this question. Of today's session. Stay glued to my channel because end of term coverage part 4 is coming up on Monday. Subscribe to the channel if you haven't, and also hit the bell icon so that you don't miss on any upcoming videos. And if you like the video, if you found it useful, give it a thumbs up, share it with your friends who are going to give their exam shortly so that they will also benefit and help from the video. Until then, this is Miss Ruchika signing off from today's session. See you in my next video. Bye, students.